Do you have difficulty with math? Worry no more, because I have a solution for you. Let's have math classes with Mamshi. See you in class! Welcome to our class in Pre-Calculus Week 4A. Our topic is about the hyperbola. And our objective is, at the end of this discussion, the students will be able to define a hyperbola and determine its parts. What is a hyperbola? It is the locus or the set of all points in a plane such that the difference of whose distances from a two fixed point called foci is a positive constant. And so, we have here the term focal axis. It is the line containing the two foci of the hyperbola. So this line from here to here, if you put a line there, that will be our focal axis. And also, we have the center. It is found on the focal axis midway the foci. So this is the center of our hyperbola. Vertex. It is the point where the focal axis intersects the hyperbola. So this is the vertex. And also we have the transverse axis, the line segment connecting the vertices. So if we connect these two vertices, the line segment will be called transverse axis. The transverse axis and the conjugate axis bisect each other at the center of our hyperbola. And every hyperbola has two axes of symmetry and also two asymptotes. So the line dividing the hyperbola into congruent parts is our axis of symmetry. So that is your y-axis and also the x-axis. And also they have two asymptotes. So this is our asymptote, the diagonal of the rectangle that we can find here. And the distance of the vertex to the center is a units. And so, our transverse axis has length of 2a. And the distance of the co-vertex to the center is b units. And so, conjugate axis has the length of 2b. The distance from the center to its focus is c units, where c squared is equal to a squared plus b squared. So let's have now the standard equation of our hyperbola. Let c greater than a greater than 0 and b is equal to c squared minus a squared. An equation of the hyperbola whose center is at the origin with foci at c0 and negative c0 and vertices at a0 and negative a0 is x squared over a squared minus y squared over b squared equals 1. And if the center is at the origin but the foci is at 0, c and 0, negative c, and vertices at 0, a and 0, negative a, then our standard form of equation is y squared over a squared minus x squared over b squared equals 1. So, this is the example of the hyperbola. The horizontal hyperbola facing to the left and to the right, and this is the equation x squared over a squared minus y squared over b squared equals 1. And this is the example of the second case, which is a vertical hyperbola, wherein the transverse axis is found on y, and our equation is y squared over a squared minus x squared over b squared equals 1. And also, we have here the asymptotes of the hyperbola. Those are the diagonals of the extended auxiliary rectangle whose sides are 2a by 2b. So this diagonal is the asymptote of our hyperbola, this one, and also this one and this one. And the equation of our asymptotes is y equals positive negative a over b x. This is a over b because our rise here, our vertical line here is represented by a, And our diagonal line, horizontal line here is represented by B. And it's opposite with this one. Our horizontal line is A and B is our vertical line. So we have positive negative B over AX. That will be the equation of the asymptote of our horizontal hyperbola. Okay, we have here an example. Determine the coordinates of the foci, vertices, co-vertices, and the asymptotes of hyperbola with this equation. Take note that to find the foci, vertices, co-vertices, and the asymptotes, we have to find the value of A, value of B, and the value of C. So, our A here is 16. A squared is 16. So, since this is your A squared, automatically, square root of 16 is equal to 4. That will be the value of our A. Next is 9. 9 is representing your B squared. So, it means that your B is equal to 3. And so, if we are going to solve for the value of C, that will be the square root of A squared plus B squared. Our A squared is 16 plus B squared, which is 9. That is equal to 16 plus 9 is square root of 25. Okay, so our C is equal to 5. Since we already have our A, B, and C, it is easy for us to find the points. So for the foci, the coordinates are negative 5, 0, and 5, 0. For the vertices, the coordinates are negative 4, 0, and 4, 0. And for the co-vertices, since it's already on the y-axis, we have 0, negative 3, and 0, positive 3. Okay? And last one, the asymptote. The asymptote of this is y equals positive or negative. Take note that this is a horizontal parabola. So our b here is the y. And so that is b over ax. So our equation is y equals positive or negative. B is 3, x is 4. So b is 3, a is 4. So we have y equals plus or minus 3/4 x. That will be the equation for our asymptote of the hyperbola. Take note that if we have x squared here as our first term, it will automatically be a horizontal parabola. And so our a here will be this one, and our foci and vertices will be found on x. There will be a change on the value of x, but no change on the value of y. And since our co-vertex is found to be perpendicular to your vertex, since the conjugate axis is perpendicular to the transverse axis, which is made by the vertices, so our co-vertex lies on your y-axis. So that's why we have 0, negative 3 here. Let's continue with the second example. Determine the coordinates of the foci, vertices, co-vertices, and asymptotes of this given hyperbola. Take note that our first term here is y. And we can see that it is a vertical hyperbola. So let's find first our A, B, and C. Our A is square root of 4, so that is 2. Our B is square root of 16, so that is 4. And so let's find the value of our C. C is equal to square root of 16 plus 4. That is equal to square root of 20. And square root of 20 is equal to 2 square root of 6. This will be the value for our C. Okay, let's continue. Let's identify the foci. Since we have here the first term as y and it is a vertical hyperbola, so our foci will be at 0, negative 2 square root of 6, and 0, positive 2 square root of 6. Next is the vertices. The vertices will be found at 0, negative 2. Sorry, that's 0, negative 2, and 0, positive 2. However, our covertices will be found at x-axis. So that is negative 4, 0, and positive 4, 0. And lastly, our asymptote, that will be y equals, so our a here is found on y-axis, so that is our rise, positive negative 2 over 4x. Or that can be considered as y equals positive negative 1 half x. That will be the equation of our asymptote. Okay, let's continue with example 3. Determine the coordinates, foci, vertices, covertices, and asymptotes of the hyperbola given this equation. So let's try. Our a is equal to 3. Our b is equal to square root of 16, that is 4. And so our c is equal to square root of 16 plus 9, which is square root of 25. So our c is equal to 5. Since our c is equal to 5, it's easy for us now to find the coordinate for the foci. The coordinate for our foci will be negative 5, 0, and 5, 0. The coordinate for our vertices will be at negative 3, 0, and 3, 0. Next, for our co-vertices, the coordinates will be 0, negative 4, and 0, 4. And lastly, our asymptotes rather. Lastly, our asymptotes has the equation y equals b over a. Our a here is 3, so we have 3. So that is positive negative a x. Sorry, that's 3. Okay, so this one is 3. So we have 4/3 x. Okay, let's continue. For our last example, determine the coordinates of the foci, vertices, covertices, and asymptotes of the hyperbola given this equation. So let's find our a. Our a is equal to 5, that is square root of 25. Our b is equal to square root of 24, and that is equal to 2 square root of 6. And lastly, let's find our c. Our c is equal to square root of 25 plus 24, which is equal to square root of 49. So our c is equal to 7. Now, it's easy for us to find the coordinate of the foci. The coordinate of our foci will be 0, negative 7, and 0, 7. For our vertices, the coordinates will be 0, negative 5, and 0, 5. For our co-vertices, we get negative 2 square root of 6, 0, and positive 2 square root of 6, 0. And for our asymptote, it will be the equation y equals 5. Positive negative 5 over 2 square root of 6x. That will be the equation for our asymptote. Okay, let's continue. We are done now with quarter 1, week 4A. So let's continue with our quarter 1, week 4B. Okay, so welcome students for our another class. Our topic is about the standard equation of hyperbola with center at the origin. Okay, so at the end of this discussion, you will be able to determine the equation of our hyperbola if the center the center of the hyperbola is at the origin. Okay? So for the standard equation of a hyperbola, we have this equation. Let c greater than a greater than 0 and b equals c squared minus a squared. Then an equation of hyperbola whose center is at the origin is this one. If the foci and the vertex is found at x-axis, and it is this one if the foci and the vertex is found on your y-axis. This is just a review of our past discussion. So, we have also this example. If the hyperbola is horizontal, then this will be the equation. And if it is vertical, then this will be the equation. So, let's continue with our example. Find the standard equation of the hyperbola with foci at 5, 0 and negative 5, 0, and whose difference from the distances from any point on it and the foci is 6. So, as we can see, our 2a is equal to 6. And for the foci, or for our letter C, it means that it is 5 units from the origin or from the center. So, our C is equal to 5. Our 2a is equal to 6, and so our a is equal to 3. Now let us find our b. We have our a, we have our c, and so our b is equal to square root of c squared minus a squared. So we have square root of 25 minus 3 squared, which is 9. So that is 16. Square root of 16. So our b is equal to 4. Okay, so that's it. We have our A, we have our B, so it will be easy for us to write the equation. And since our foci is at x-axis, we have x squared over 3 squared, which is 9, minus y squared over b squared, which is 16, equals 1. This will be the standard equation of our hyperbola given these conditions above. So let's continue with our example 2. Determine the standard equation of the hyperbola with vertices at 0, 4, 0, negative 4. Take note that the vertices are at y-axis and the co-vertices at r 2, 0 and negative 2, 0. So if our vertices is at 0, 4, so our A is equal to 4 units from the origin. And if our co-vertices is equal to 2, 0, so our B is equal to 2 units from the origin. And so our equation will be easy. As you can see, the vertex is found at the y-axis. So we have y squared over 4 squared, which is 16, minus your x squared over b squared. So that's 2 squared, which is 4, equals 1. This will be the standard equation given the situation above. Okay, let's continue with our example 3. Determine the standard equation of the hyperbola with co-vertices at 0, 3. Take note that the co-vertex is at 0, 3. And whose difference of the distances of any point from the foci is 10. So, our 2a is equal to 10. And so, our a is equal to 5. On this case, our b is equal to 3 since it is 3 units from the center of our hyperbola. And let us find our c. Our c is equal to square root of a squared plus b squared. So that is 25 plus 9. So our c is equal to square root of 34. So since we don't have a square root for 34, let it be like that. So the standard equation of our parabola will be, since the co-vertex is at y, automatically our vertices will be at x. So we have x squared over 25 minus y squared over 9 equals 1. Okay, so this will be the equation for our example number 3. Let's continue with our example number 4. Determine the standard equation of the hyperbola with vertices at 0, 3, and 0, negative 3. So these are the vertices at y-axis and whose foci it is at 0, 5, and 0, negative 5. Take note that your A is equal to 3 since it is 3 units from the center. Your C is given as 5 because it is the coordinates of your foci. And if we are going to find the B, that is equal to the square root of C squared, which is 25, minus square root of A squared, which is 9. So B is equal to square root of 16, and so our B is equal to 4. So it's easy for us now to find the equation. Since we have the vertex at y, so we have y squared over 3 squared, which is 9, minus x squared over 4 squared, which is 16, equals 1. This will be the standard equation given the situation on example 4. So we are now done with quarter 1, week 4B. And lastly, let's have our class in pre-calculus week 4C. Our topic is about the standard equation of hyperbola with center at HK. At this time, our center is not at the origin. And at the end of the discussion, you will be able to determine the equations of our hyperbola, given the center not on the origin. So let's start. The standard equation of the hyperbola. Let's see greater than a greater than 0 and b equals square root of c squared minus a squared. Then an equation of the hyperbola whose center is at hk with given foci. So this one has changed in x, and so the vertices has also changed in x. So we have x minus h quantity squared over a squared minus y minus times minus y minus k quantity squared over b squared equals 1. And also, if the foci has changed in y and the vertices have also the change in y, then the equation of our hyperbola is y minus k quantity squared over a squared minus x minus h quantity squared over b squared equals 1. Let's have here the example. So first, determine the center, vertices, co-vertices, foci, and the asymptotes of the hyperbola, given this standard equation. So, to determine the center, it's easy for us because this will be our h and this will be our k. So, the center is at the point 2, negative 3. Now, since we have the center at 2, negative 3, take note that we have x here. So it means that for the vertices, there is a change in x. There is a change in x. And so, since we have 64 here, our a squared is 64. So, our a is equal to 8. That is square root of 64. Now, our b is equal to square root of 36. So, our b squared is 36. And so, our b is equal to 6. And lastly, in order to find the foci, is we have to find your c. So, our c is equal to square root of b squared, which is 36. That's 36. Plus square root of a squared, which is 64. So that is 36 plus 64 square root of 100. So our C is equal to 10. This time, it is easy for us to find the vertices. Vertices is at, so we'll have a change in x. 2 plus 8. Oh, let's start with 2 minus 8. We get negative 6, negative 3, and 2 plus 8 is 10, negative 3. So there is only a change in x. Let's find the co-vertex. For co-vertices, there is a change in y. So we have to copy 2 and negative 3 minus 6, that's negative 9. And the other one, that is 2, negative 3 plus 6, that is positive 3. So this will be the point of our co-vertices. For the foci, we have change in x also. So that is 2 minus 10, we have negative 8, negative 3, copy your negative 3, and 2 plus 10, we have 12, and copy negative 3. And for our asymptote, take note that when we are making an equation, our equation will be y minus y sub 1 equals slope, so that's m. You will solve for m, then multiplied by x minus x sub 1. So let's apply that in our finding the equation of asymptote. So we have y minus 2 equals, the slope is, since it is an x, our b here will be our numerator and our a will be the denominator. So that's 6 over 8. Positive, negative, 6 over 8x times x sorry, no, it's not y minus 2 but y plus 3. Okay, y plus 3, that is the center, then x minus 2. Okay, so if we are going to reduce this and also transfer your 3 on the right side of your equation because it does not belong there. You only have to have y here. So 3 will transfer here on the right. So we have 3 plus or minus 6/8 is equivalent to 3/4 of x minus 2. That will be the equation for the asymptote of the given hyperbola. Let's continue with example 2. Take note that our denominator here is 1. So our a is equal to square root of 25, which is 5. Our b is equal to square root of 1, which is 1. And our c is equal to square root of 25 plus 1. So c is equal to square root of 26. It doesn't have a square root, so just let it be. So let's find the center first. The center is at 4, 6. So since there is a change in a, so the vertices will be minus 5 and plus 5. So the vertices will be at 4 minus 5, that's negative 1, 6. And 4 plus 5 is 9, 6. Co-vertices. Our co-vertices will be at change on y. So we have b, 6 minus 1 is 5. And 4, 6 plus 1 is 7. Next is the foci. So our foci will be change in x also. So that's 4 minus square root of 26, 6. And 4 plus square root of 26, 6. That will be the value for the foci. And last one, the asymptote. Okay, so the asymptote will be y minus 6 equals 1/5 positive or negative 1/5 times x minus 4. So that's it. So we have y equals, from negative 6 that becomes positive 6 plus or minus 1/5 times x minus 4. That will be the equation for example 2. Let's continue with example 3. Take note that our transverse axis is now at y. So our a is still 5. Our b is square root of 11. And our c is equal to square root of 25 plus 11. Our c is equal to square root of 36, and so our c is equal to 6. So we have now our a, b, and c. So let's find the center first. Center is at, your x is here, so we have x coordinate of 2, and also your y is here, so 1. The center is at 2, 1. So for the vertex, there is a change in y. So for the vertices, we have change in 1, copy or 2, then 1 minus 5, that is negative 4, and 2, 1 plus 5 is 6. That will be for the vertices. For the co-vertices, there is a change in x. So let's start with square root of 11. So we have 2 minus square root of 11, 1, and 2 plus square root of 11, 1. That will be the answer. And for the foci, also it is a change in y. So we have 2, 1 minus 6 is negative 5, and 2, 1 plus 6 is 7. Okay. For the asymptote, we have y minus 1 equals plus or minus a, so that's 5 over square root of 11x. Or you can simply write that as y equals positive 1 plus or minus 5 over square root of 11x. Okay, that will be the answer for our number 3. Let's continue for number 4. Find the standard form of the equation of the hyperbola centered at 1, 2. So we have x minus 1 quantity squared minus over blank minus y minus 2 quantity squared equals 1. So we have to find the values here. Okay. With transverse axis of length of 10. So 2a equals 10. Our a is now 5. So as you can see, our a squared here is 25. And the foci is at negative 5, 2, and 7, 2. So the distance between negative 5 and 7 can be found. So let's find out if what is the distance between them. That is 2c. So we have negative 5 minus 7 equals the distance between them. That's negative 12. Absolute value, because we are speaking of distance, so the distance is 12. And so our 2c is equal to 12. Therefore, our c is equal to 6. Okay? Since our c is equal to 6, let's find our b. b is equal to square root of 6 squared, which is 36, minus a squared, which is 25. So 36 minus 25 equals square root of 11. So our b is equal to square root of 11, and so our b squared here is 11. This will be the standard form of the given equation. Let's continue. Determine the standard equation of the hyperbola with the foci 4, negative 2, and negative 6, negative 2. Take note that foci is represented by c, and the distance, there is a change in x. So let's find first the distance between 4 and negative 6. We have 4 minus negative 6. That is absolute value of 4 plus 6, which is 10 units. So 2c is equal to 10, and so our c is equal to 5. And also the vertices, which is 2, negative 2, and negative 4, 2. Let's find also the distance between them. So that will be absolute value of 2 minus negative 4 equals absolute value of 2 plus 4. So that is 6. It means that our 2a is equal to 6, and so our a is equal to 3. We now have our a, our c, and what is missing now is our b. So our b is equal to square root of c squared minus a squared. So let's substitute. C squared is 25, a squared is 9. So 25 minus 9, the answer is 16. Our b is equal to square root of 16, which is now 4. Okay, we have now our a and b. It's easy for us now to write the equation. And since there is a change in x, so we have here x. X, where is the center? So the center is midway of the foci or also midway of the vertices. So if we have our x value here of 2 and the other one on the left is negative 4, so what will happen? Since the distance between them will be our a, which is 3, so that is negative 4 plus 3, negative 1. So our center will be at negative 1 and our coordinate for the y will be negative 1, negative 2. So let's have x plus 1 quantity squared over our a, which is 3, so that's 9, a squared, minus y plus 2 quantity squared over our b, which is 4, so that is 16, equals 1. This is now the standard form of the equation. Again, take note, in order to find the center, you have to identify what is the middle point or the midpoint of the two given vertices or the two given foci. In that case, you are able to identify the value of our center. So since the vertex is negative 4 and our a is 3, so negative 4 plus 3, that is negative 1. Same thing, we have negative 6 here. If we add 5 to our negative 6, the answer is still negative 1. So it's midway our foci and also midway our two vertices. And the equation will be like this. X plus 1 quantity squared over 9 minus y plus 2 quantity squared over 16 equals 1. Let's have our example 6. Determine the standard equation of the hyperbola with focus at 12, 3, vertex at 4, 3, and center at negative 1, 3. Take note that our vertex and focus, okay, take note first that our vertex is how much? That is 4, 3. Our center is negative 1, 3. So let's find the distance from the center to the vertex. So the distance from the center to the vertex, since there is a change in x, let's see. So we have absolute value of negative 1 minus 4. That is absolute value of negative 5. So from the vertex to the center, which is our a, the distance is positive 5. Now let's continue finding the value of our C. Okay, since we have given the focus here, so let's find our C. The distance from the center to our focus is absolute value of negative 1 minus 12. So that is negative 13. And so our B is equal to 13. Sorry, it's not B, it's RC. From the focus. So since the focus is our reference, we have our C. And last one, we have to find our B. So B is equal to C squared minus A squared. C squared is 169 minus A squared, which is 25. So that is square root of 144. Our B now is equal to 12. Okay, so we have now our A and our B. Let's have our equation. As you can notice, there is a change in x and no change in y. So we have here x plus 1. This is our center. Quantity squared over a squared, which is 25, minus y minus 3. Quantity squared over b, 12 is 144, equals 1. This will be now the standard equation of our hyperbola if the vertex, the focus, and the center is given by that quantity. So, we are done now with quarter 1, week 4C, and I hope that you have learned a lot from me. So, please just comment down below what you want to learn more in mathematics so I could give time to make more videos that will help you guys. Thank you for watching, and also please like this video and subscribe to my channel. For those who are new to my channel, just subscribe to my channel, click subscribe, and hit the notification bell to be updated of my latest videos. Thank you for watching, and I hope you learned a lot from me.